Welcome back everyone. My name is Sagar and we are back here with another video. So this is the lecture number 24 of our Java and DSA course. And finally the day is here. So today we are gonna learn about time and space complexity. But remember that thing, we are not gonna learn everything about time and space complexity because first we have to also learn about recursion and also reconciliation. And then we will dive deeper into this and we will also learn a formula to find your time and space complexity. But today in this video we will just cover the basics so that you can just estimate your time and space complexity of your algorithm and you don't panic while you are listening to those words, what is big O, what is O of n square, so that you can have a basic understanding. So without making any further ado, let's get started. So first of all, what is time complexity? So as you can see here, it is the amount of time taken by an algorithm to run as a function of the length of our input. But Sagar, that's just a geeky definition from the internet. So let me just explain it to you. First of all, keep that thing in mind. Time complexity is not the amount of time taken. It is just the estimate. Or we can say it is just a relative thing that totally depends on the size of your input. So time complexity is something that will tell us how our time will grow as our input grows, or we can also say how our time is dependent on the size of your input. So you already know that we have these notations, big O of n square. So we have these kind of things, so that n was here the size of your input and this big O is just asymptotic notation. So we will also learn about that. So that is how we have to represent our time complexity, not like that your program takes 0.01 millisecond to run, though that is not time complexity, that is just a time. And also that totally depends on the machine that you are using. So suppose I am writing some program in some old machine. So suppose there is some old computer and there is new MacBook Pro. So suppose you are just writing the same program in this laptop and the same program in this computer. So just for an example, this algorithm takes 0.5 millisecond to run and this algorithm in this MacBook Pro is taking 0.001 millisecond. So can we say the time complexity of the algorithm that we are running here is less? No, we cannot say that. The time complexity of both the algorithms, if the algorithm is same, the time complexity is exact same. So suppose the time complexity is big O of n, but still they can show a difference in the actual time. Here time can be 0.5 or it can be 10 millisecond or something else. But actually we don't have to care about this thing. We only have to focus on this. This is the time complexity of our algorithm, that is O of n. And that is showing how our algorithm is dependent on our input. And now the question is why we care about this thing and not this thing, and the answer is because we need some generalized thing. As you can see, this thing, this exact time directly depend on your computer. Either you are using a fast computer or a slow one. But when we are talking about our time complexity, this big O of n, that is a kind of generalized thing. This thing is exact same for our slow computer and also exact same for our fast computer. So we have to focus on this generalized thing and calculate it for our algorithm so that we can also compare and optimize it with other algorithms. So now you know why we need this time complexity, because we have to compare our algorithms. And let me tell you that this is a very important topic and you will be definitely asked for this in your interviews. So after you write some algorithm, you have to tell its time and space complexity. And you also have to know about this so that you can also optimize your algorithms like we were doing in our previous video. So now let me just show you some example. So suppose for an example, I want the sum of first n numbers. So I will just take that n from our input, new scanner, and after that this n. So I am taking a number from our input and our algorithm is to find the sum of first n numbers. We already learnt about that algorithm. So I will just start a loop from 0. So from 1 or 0 you can do anything and it will go up to n and I plus plus. So I will also create a variable that will store our sum, int sum equal to 0, and every time sum will add I, and at last I will print sum. So that is a very simple program, you already know about that. So suppose for an example I want the sum of first 10 numbers, so it is 55. So what is the time complexity of this algorithm? I will say big O of n, and n is the size of our input, that is here n. So we are traversing from 1 to n. So what we are doing, every time what we are doing, you can see. So at very first step we initialize this value with 1, so I is equal to 1, and after that what we will do, we are checking is I is less than n or not, and you can see I is less than n for our input value 10. So I is less than equal to n, and after that we will enter in this block. So what we will do, sum plus equal to I. So this is our first iteration. So sum plus equal to I, that means sum will be equal to 1, and after that, after this line, after first iteration I will be increased, so I will be here at 2. And after that we will check these things, is I is less than 2 or not. So I is equal to 2 and it is less than 10, so we will again do this thing. So after that, this one plus this 2, so it will be 3, and it is again stored in this sum value. So sum is equal to 3, and after that I will be increased, so again we will add these two things. So 3 plus 3 is 6, and it will be back stored into our sum. So I was 3, then it will be 4, 5, 6, 7, 8, 9, 10. So we were starting from 1 and we are moving up to 10 with all numbers. So we are checking and adding all numbers from 1 to 10, and that is from 1 to n. And the operation every time we are doing is checking and incrementing and also adding to our sum. So these three are operation we are doing every time. So as in our previous videos, I already told you that consider time complexity as the total number of operation we are doing. But here you can see what we are doing. First we initialize, so this is our first operation. Then we are checking, so first initializing, let me just write it here. So what operations we are doing? Initializing, and after that we are reinitializing, so that is also our operation. So first operation. Second operation is checking for our null case, that means we are checking if I is less than n or not. And after that we are also doing a third thing, that is adding to sum. So these are the three things that we are doing here. And we are doing these three things how many number of times? Total 10 number of time, and that 10 is equal to our n. So the time complexity will be O of n. So let me just write here 10, 9, 8, that's 7, that's 6, that's for 5. So you can see what we are doing every time. First we initialize, then we are again reinitializing. We are doing these three steps how many number of times? You can see total of n number of times. So that's how you can see the time complexity is O of n. But we can optimize it. Optimize means that we are reducing our time complexity so that our algorithm will run very fast. So our algorithm is big O of n, and I will just tell you what is this big O notation. But currently we have to optimize our algorithm. So for optimizing our algorithm, we have to find the sum of first n numbers, and I know that formula. So sum b is equal to n into n plus 1 by 2. So that is the formula to find the sum of first n numbers. So I will just print this sum b, and after that I have to check. So sum of first 10 numbers is 55. You can see our first sum is 55, which we are finding using a for loop. But after that we are using a formula to find the sum of first 10 numbers. So you can see the answer is same. So here we optimized our algorithm, and here the time complexity is of 1, because as you can see we are doing only one operation. But why here the time complexity is of n? Because you can see here we are doing 3 steps, so it should be 3 into n, because we are doing 3 steps n number of times, so it should be 3n. But why am I saying the time complexity is O of n? And that is because of this big O notation. When we are using this big O notation with some value inside it, it will just change it. When I'm writing here big O of 3n, so it will just change it to big O of n. So here our time complexity is O of n. So now this is the main question, what is this big O notation? So that is one of the asymptotic notation we have. So we have this asymptotic notation, and that are kind of similar to the kilometer or a meter that we have to find our distance. So also as we use minutes, seconds and hours to represent our time, these are asymptotic notations that we can use to represent our time complexities. So the main that is very important thing is this big O notation that we will use always. And that is the only thing you need to know about your algorithm. But there are also some other things like this big O notation and big theta notation, and there are also some other things like you can see there is small one little O notation, and there is also something like that. You can see here there is this little omega notations. They don't have that much use, but you need to know about them. So what is this big O notation? So big O notation is used to represent the worst case time complexity of your algorithm. So it is represented by this big O symbol, and after that inside this parenthesis we write something like big O of n. That means our time will increase linearly as compared to the size of our input, or we can also say n square. So if you can remember, that was the time complexity of our bubble sort algorithm. So big O is used to represent the worst case time complexity. So this big O is used to represent the upper bound, that is the maximum time complexity that our algorithm can take. So this is big O of n square, and that means our algorithm can maximally take O of n square time. It can take also less time. So like for an example, I will take the simplest algorithm. Like we have to do a linear search. So suppose I have this number n equal to 1, or we can say x equal to 1, and we have to find that number in our array. So I will also create an array, ARR. So suppose this is our array and we have to traverse in our array from 1 to 5. So if this ith character is equal to x, then we will just print here found and we will just break. So, so you already know that this is our linear search algorithm. We have some number and we are finding it in our collection. So what is the time complexity? Here the time complexity is of n. So of n, and you can see we are traversing from 0 to n. Suppose this is not a fixed number and it was from our input. So the time complexity will be of n. And you can see I'm writing here the worst case time complexity, that is big O of n. And that means in worst case I have to check all the n numbers to find this x. So in worst case, I have to check all the n numbers, but my time can be also lesser than this. So suppose for an example, my 1 is at first index. So what is now the time complexity? Time complexity is of 1. If I am talking about the best case time complexity. So that is the best case time complexity. The number that I have to find is on the first index. So when I enter in the loop, I just found that the first index element is equal to my number. So I will just break with checking only one number, and the time complexity, the best case time complexity, and that is represented using this big omega notation. So we can write it as big omega of 1, and that is the best case time complexity in our linear search algorithm. You can see here the number we have to find is on the very first index. So we will just enter and we will just break by just checking the first number, and we just found our number in one iteration. Every time our number is not on the first index, it can be here, it can be at the last index. So that's why we have to consider only the worst case time complexity. So I hope now you got this, why this is called as upper bound. Because upper bound, that means it is the limit, our time complexity cannot exceed this. So big O of n means, that means maximally we have to check only n numbers, and it can be also less than n. So that is what time complexity is. So that is what big O means. And we also saw that big omega notation, that is used to represent the lower bound. So this big omega represents upper bound. Upper bound, that is the worst case time complexity. Worst case, this omega represents the best case, that is the lower bound. So lower bound means the minimum time that our algorithm will take. So that is, you can see here, we have to find a number, and the minimum time that we can take is of 1. That is, at least we have to do one operation to find some number in our array. So that is the best case time complexity. We can write here, it shows the best case time complexity, and it is the lower bound. Lower bound, it represents lower bound. So now what are these little o and little omega notations? You can also see here, there is this big O and there is also this little o. So big O means the upper bound that is reachable, that our algorithm can also take O of n time, O of n square time. And little o means the upper bound that is not reachable. So if I am writing it as O of n, little o of n, that means this n is not reachable. Our algorithm will definitely take time lesser than n. So that is called as little o notation. And big O of n means our algorithm can take O of n time, and it can also take time lesser than n. So that is the only difference between big O and little o notation. And that is the similar case with big omega and little omega notation. Big omega means the lower bound, that is the minimum time our algorithm will take, that is reachable. But in our little omega notation, it also represents lower bound which is not reachable. So I hope now you understand these things. And there is also another asymptotic notation, that is big theta. So we saw the best case, we saw the worst case. So what is this big theta means? So this big theta represents both of them. So suppose for an example, our time complexity is n in our best case and also n in our worst case. So suppose in this example, so in this algorithm, when we are finding the sum of first n numbers, so this is the algorithm that we are writing, and in our worst case the time complexity is, we have to check from 1 and go up to n. So time complexity is of n. So if we are taking that n from our input value, then we have to write our time complexity in terms of that input value. So time complexity is of n. And when we are talking about best case, so in best case we also have to traverse from 1 to n. There is no condition, so that is a must. We have to traverse from 1 to n, and that is also the best case time complexity. So when our worst case time complexity is O of n, and when our best case time complexity is O of n, sorry, omega n, then we have to write it as big theta notation, and that is represented as this theta. So that is also, you can say, the average time complexity of your algorithm. So basically you don't need to focus on all these things. The main focus is on this big O notation, and that is the only thing you will be always asked. So now let us see how can we find out time complexity using this big O notation. So first of all, like we just saw in this algorithm, the time complexity was The total time it was taking was 3n, but we were writing it as big O of n. So what is this thing? Why we are writing it as this? The time complexity was 3 into n, but we are writing it as O of n. So that is one of the rules of writing our time complexity with big O notation. So now what are the rules? Let me just write here. So our first rule is we have to select the greatest value of all the things. We have to select greatest power. Greatest power. So what is this greatest power means? So suppose for an example, let me just clear it first. So suppose for an example, our time complexity of some algorithm is n cube plus n square plus 1. So n cube means, suppose for an example, I am running 3 nested loops, and after these 3 loops I am running 2 loops and then sum of one operation. So that is the total time we observed from our program. But when we are writing with the big O notation, so we only have to consider the greatest value. That is, our time complexity will be n cube. And I will also tell you why this thing is here. Why we have to select only the greatest value out of our whole algorithm. So that was the rule number 1. And after that, the second rule is ignore constants. So that is the second rule, and let me just tell you why it is. So suppose for an example, I observed the time complexity of my program is 3n cube, and when I'm writing it as big O, so it will be considered as O of n cube. But why we have to ignore this constant? Why we have to do that? So suppose for an example, the value of n is 1000. So if n is equal to 1000, then n cube will be equal to 1 2 3 1 2 3. So this is something very huge value. That is the value of n cube, and when we are multiplying it with 3, so it will be here, it will be 3. So suppose when we are talking in Hindi, so suppose I am saying time complexity करोड़ों में जा रही है, so वो 1 करोड़ भी हो सकते हैं, 3 करोड़ भी हो सकते हैं, but why should we care for our constant values? So I can directly say time complexity करोड़ों में जा रही है. So that is the thing you can understand with. So simply we don't have to care about this constant, and we can say time complexity करोड़ों में जा रही है. So in worst case, our time complexity will be big O of n cube, and we have to ignore all the constants. And these are the only 2 rules that you have to follow. So now let me just show you some examples of valid time complexities. So now let us do some practice and find the big O notation of all these times. So we have to follow our 2 rules. First of all, we have to take the greatest value, greatest power. So you can see this is square power and this is log n, this is root n. So it is 1 by 2 power here, है ना? So we have to first take the greatest value, and that is 4n square. And after that, and after this step, we have to ignore all the constants. So it is big O of n square time complexity. And in this, we have to take the greatest value. This is n log n, this is n root n. How can we know which one is greater, n log n or n root n? So log n or root n, which one is greater? You can just try to put some large values, and you can see root n is greater. So we will just take this root n, n root n. So that is our time complexity, n root n. And after this one, so what is maximum out of these 4? So this 2 to the power n is the maximum one, but how can we know? I will just tell you. So for now, just remember this 2 to the power n is the greater one, so we will just take that out. You can also take this one, or you can take this one. That's totally your choice. The time complexity will be 2 to the power n, and that is called as the exponential time complexity. This one is called as the quadratic time complexity, and this one is called as the exponential time complexity, because here n is in the power of some value. And in the next one, you can see n square log n or n cube, which one is greater. So you can just verify by yourself, n square log n or n cube, which one is greater. So n square से n square गया, so here we will get n, and here log n or log n, which one is greater? Obviously n is greater. So that means our n cube is greater than n square log n. So we will just get here n cube, and that is the time complexity in our worst case. And after this line, which one is greater? Here in our next one, this is our 3 into n into 2n, and this one is 400 into n ki power 4, and after that we have n factorial. So if you don't know, let me just tell you, n factorial is the greatest one. So our time complexity will be factorial. But how do I know that n factorial is greater than this n to the power 4 or this exponential? So let me just tell you by creating a graph. So here is our graph, and first we will see what is the value of O of 1. So if we are writing O of 1, that means our time complexity is constant. So suppose for 50. So suppose that is O of 50. So we will draw a linear line here. That is it. That is the time complexity of our O of 1. After that, we will see how O of n looks like. So how can we draw O of n? So this is our size, that is the length of our input, and that is our time. So O of n means if our length is 1, then we will take 1 second. And if our length is 5, then we will take 5 seconds. If n is 10, so if the value of n is 10,000, then we will take 10,000 times to run this algorithm. You can just remember it like this. So O of n is a linear time complexity. And after that, we have what is greater than O of n. So we have O of n square. So O of n square means we have quadratic time complexity. So how the graph of n square looks like? So it is something like this. And after n square, we have O of n cube. And the graph of n cube will be something like this. And after that, we have n to the power 4, 5. You can take any values. And we also have log n. So what is the time complexity of log n? How the graph looks like? So the graph of n log n is something like this. And after that, we also have n log n and log n. So the graph of n log n looks something like this. And we also have the important ones, that is 2 to the power n, that is exponential, and n factorial. And the graph of 2 to the power n is something like this. And then the graph of n factorial is more worse. So how can we compare these time complexities by using this graph? So first of all, you can see we have to check for worst cases. That means when our input value is much greater. So you can see, suppose for example, so suppose when the size is equal to 10,000, then we have to check. So what is the best time complexity that you can see here, which is taking minimum time? So minimum time that you can see here, it is O of 1. So here O of 1 is the best time complexity. And after that, you can see here it is log n time, O of log n. So after O of 1, we have log n time. So log n time is greater than O of 1, but it is still better than O of 1 time. You can see after that we have O of 1. So O of log n is better than O of n. And after O of n, you can see here we have O of n log n. So it was n log n. Log n. Here we are writing them in increasing order of their time. So after O of n, we have big O of n log n. So n log n time is greater than O of n. And after this log n, what we have, this is O of n square. So n square. So n square will meet somewhere like there. So n square will definitely meet there. Don't worry, but it will obviously take time. So n log n is lesser than O of n square. And after n square, we have this n cube. So n cube will also reach there. Somewhere it will definitely reach that value. And that means n square is lesser than O of n cube. And after that, we also have this exponential. So exponential will definitely meet somewhere. So exponential is one of the worst time complexities. After that, we have exponential 2 to the power n. And after that, remember that thing, factorial time complexity is the worst time complexity. So you should never have this in your algorithms. So do you have to remember this whole order? No, you don't have to remember the whole order, which time complexity is lesser than which one. So how can you check which one is greater and which one is smaller? You know that n is greater than log n. So that is obviously some function of n, and you know that the n power is obviously greater than n. So just don't worry about learning this whole thing. After practicing, after finding time complexity of so many algorithms, you will get used to it. So let me just also show you one thing, that suppose this is the graph of our linear search algorithm, that is O of n, and suppose I am writing here O of n by 2. So what is the graph of n by 2? So that is something like this, but they are equal. This is the graph of n by 2, and this is the graph of O of n. Not O of n, this is graph of n. But when I'm using here big O notation, then they both are equal. So they will be represented as big O of n. So like in our previous video, so that is in our task number 23, we were finding the algorithm. We were traversing in this array, like, yeah, you can see here. We are traversing in half of our string. So if you don't know, you can just check out our previous video. So it was like, this is the length of our string n, and we are traversing from 0 to n by 2. So the time complexity should be n by 2. But when we are writing with big O, then it will be represented as big O of n. So that is the thing I wanted to show you. So you also have to remove this, ignore this constant. So n by 2, this 1 by 2 is also a constant. So you also have to ignore this, and the time complexity is O of n. So let me also tell you one thing, that if the time complexity of your algorithm is much higher, then you will get error that is called as time limit exceeded. So that is just a thing called as TLE, and you have to optimize your algorithm to ignore this time limit exceeded error. So here are some important things that you need to know to ignore this time limit exceeded. So if our value of n is less than or equal to 12, so you will be given some constraint in your algorithm, like we were doing our question in our lead code platform. So you will be given the range of your n value. So if the n value So if the value of your n is greater than equal to 10, then the time complexity can be O of n. So you can write some algorithm that will run in O of n factorial notation. And after that, you can see if the value of n is lesser than or equal to 25, then you can write some algorithm that will run in O of 2 to the power n, 2 to the power n. So that is the exponential time complexity. So you can write some algorithm that will run in exponential time complexity. And if your value of n is lesser than equal to 100, then you can write some algorithm that run in n ki power 4. And if value of n is less than equal to 500, you can write some algorithm that have a time complexity of n cube. So it will just run. It will not give a time limit exceeded error. So if you are aware of these constraints, then you will not get the time limit exceeded error. And if value of n is 10 to the power 4, then you can write some algorithm of n square. And if we have 10 to the power 6, so if the range is up to 10 to the power 6, then we can write algorithm of n log n. If we have 10 to the power 8, then we have to write O of n. If we have greater than 10 to the power 8, then we have to write O of log n or O of 1. So you will need this last 4 value of 1. So you have to remember this. If 10 to the power 4, then n square. If 10 to the power 6, then n log n. And that is because of 10 to the power 8 rule. So that means our modern machines can run 10 to the power 8 operations per second. Just remember these things, and after that let me just give a quick about space complexity. So what is space complexity? So it is exact same as our time complexity. It is the amount of space taken by our algorithm as a function of the length of our input. So when we are writing it with big O notation, so it can be O of n, O of 1. So these are also the same thing, but remember that thing when we are using just variables. So you can see when we are just creating variables like this, so they were taking of one time. So we will not consider them. So if we are taking three variables, so we are writing of 3 and it will be eventually of 1. So we have to check overall time complexity of our algorithm. So suppose we are creating an array of size n. So that time complexity will be O of n. That n is the size of our array, but that is not the auxiliary time complexity. So there are two things, space complexity and auxiliary space complexity. So auxiliary means the extra space that we are using to solve our algorithm. Here we are just using our array as an input. So that is not the auxiliary time complexity. And in our platforms like LeetCode, we have to find the auxiliary time complexity. Sorry, space complexity. So here we are taking no extra space. So that is the space of our input. So if we have to find the overall space complexity, it will be O of n. But if we have to find the auxiliary space complexity, then here we are creating only extra one variable, here two variable. So auxiliary space complexity is of 1. So that is all about space complexity. Rest of the things will be same as time complexity. And now it is time for your practice problem. So today in your task 24, so first of all, I forgot something to tell you in this video. So here, suppose we are given a loop that is from 0 to n. So time complexity of this loop is of n. So of n time complexity of this loop, and after that we have another loop that is running from 0 to m. So time complexity of this second loop is O of m. So the total time complexity of this both algorithms will be, so this is O of n, this is O of m. So after that we can add, and the time complexity of this overall program will be O of n plus m. So here if we have some two different variables, so the time complexity will add. And suppose if this is from 0 to n, so this is n plus n, and after that it will be 2n. So overall time complexity will be O of n eventually. But if we have two variables, two different values, so if it is 0 to m and if it is 0 to n, so O of n it is, O of m it is. So then after all time complexity will be O of m. So that is the thing I wanted to tell you. And after that, in this today's task, first of all, you have to find the time complexity of these three programs. So first of all, here we are running two loops, that is from n and m, and after that in this second program here we have 0 to n, and here it is 0 to k, and after that I is incrementing k times. So every time I is incrementing k times. So also find the time complexity of this and share your code, share your answer in the comment section. And after that time complexity of this will be from here you can see I is starting from 0 and incrementing k times, and j is starting from 0 and incrementing k times. So share your answer in the comment section, and the first one to comment the answer will get a huge shout out in the upcoming video. So that is it for today, everyone. If this video is helpful, go hit the like button and also subscribe to our channel, and thank you for watching.